So I'm originally an environmental engineer from the Technical University of Denmark. And so that's a 5-year master degree in most aspects of environmental engineering. But then I went on to work with geochemists. So for 10 years, I was doing groundwater geochemistry work, a lot of field-based work, a lot of experimental work, so often out and about doing things. And then when I came to Australia in 2006 to take up a postdoc, I started to work on surface water groundwater interactions around Australian catchments, also looking at water quality aspects, impacts on downstream water users from depleting rivers and streams, looking at impacts on water quality and impacts on ecology. I've also worked with local Aboriginal communities on their water issues, and I've done some work in the South Pacific on Vanuatu looking at groundwater issues. I believe in trying to create a more equitable and just society, and so that means spending time and effort in places where some of those basic needs of clean, reliable, and safe drinking water, for instance, and sanitation, I think that's a big challenge, and that's something that we need to meet in order to make a more equitable and just society. I've done a little bit of work in Zimbabwe on water supply, and where there was a conflict between town users for the second largest town in Zimbabwe and the local farmers, and we were trying to work out the baseline data as well as the characteristics of the aquifer and how it could best be shared between farmers and the local township. So I guess the Zimbabwe job was more like an opportunity that came up with some of my supervisors at the time asking me whether I'd be interested to join the job, and it sounded like an adventure. And so I think it was more later on when I started to have an opportunity to work with Aboriginal communities in Australia and some of their water problems, and that was probably far more thought through and then motivated by wanting to make a difference, wanting to help out disadvantaged communities in Australia, and making sure that they have access to safe and clean water. So one is the Walgett community in northwestern New South Wales. They're on the Namoy River, and over the years they've seen the river disappear, and they've seen the river degrade in quality. And so what used to be a very important waterway for catching fish, collecting mussels, go for a swim, and all the cultural and spiritual things that comes with it, it's now a very polluted and often not flowing river. Up in the Northern Territory in Borroloola, where they live downstream from a very big mine, a big zinc mine, and they have concerns about the quality of the river water being polluted from the mine. They had a period of time where they had heavy metals in their drinking water and they thought it came from the mine. It turned out, and we helped them solve that problem, it turned out that it was naturally acidic water and a bad choice of piping and joints. And so some of the sort of acidic water would release metals from some of the construction material.
Okay.
But an ongoing problem they have is their fear of what's coming out of the mine, how it's contaminating their river, again, which is a source of food, recreation, spiritual connection, and that's a very big problem. It's an ongoing problem that we're working with them on. So there's no sort of one answer to this. In Walgett, the community is very active around improving different aspects of living in Walgett. So the elders group have a vision, they have a strategy, and it's a strategy that's very holistic around health, water, environment, youth justice, schooling. It's they try and embrace the whole gamut of problems. And so we're trying to help them with the water side. But because they're so engaged and have done a lot of thinking, they are in many ways already quite informed. In the Northern Territory, it's not quite the same. They're still very engaged, but I think there's more of a gap in terms of the understanding of processes, of terminology. And one of the mistakes that's been done a lot up there, especially from the mine and from the government, is that they've given them documents and they can't sit down and read them. They're not going to get the information they need out of that. And they keep saying, you've got to come out to us and sit with us and talk with us. And we've done that a couple of times. And I feel we need to do more of that. But you can't hand them a big fat report. It has to be very much person to person, which is both a cultural thing. It's the way of communicating. And it's also a matter of ability to both read, but also read technical stuff. And so the communication has to be very much face-to-face and repeated. One of the biggest criticisms they've had is, the expression in the mining industry where you fly in, fly out, and as a way of working. You fly into the mine, you're there for a week or two, you fly out again. And they use the same expression for scientists and academics and government people. And they've changed the expression to fly in and fuck off, because they say people come out once and then they never see them again. And so there's no continuity. There's no building relationships. And that's one of the things that they say is most important for these kind of things to work, is that it's a continuous relationship that's built over a long time that provides the trust,
confidence,
the confidence, the trust, and over time the ability to work together.
My name is Brett Miller. I work at the Water Research Laboratory. I'm a technical expert, I suppose, in water quality, water movement, rivers, estuaries, environmental things along those sort of lines. I've been working for 30 odd years in this field, so I really enjoy the technical side of work, and I really enjoy working on things that have an impact on the world. So look, from my perspective, humanitarian engineering, I think, falls into 2 or 3 different areas. There is sort of helping people with resources and helping build things and helping break that cycle of poverty. There's also empowering people to be able to make their own decisions and have their own technical knowledge. And I guess that's where most of my work on humanitarian engineering has come in. It's about training people in the developing world. So let's talk a little bit about the Myanmar project. So in Myanmar there are several, now obviously there's issues going on in Myanmar at the moment. They've had ethnic issues, and they've also now got the coup taking place. So it's difficult when you see a country that is trying to break free of some of its history, constantly being dragged back into things. I was there at the time looking, the Arawiri River is, as I said before, is a long, free-flowing river. It has a great deal of pressures on it as the community increases, as the population increases. So it's one of the main connections for shipping, and you can actually get large ships more than 1,000 kilometres up the river. However, it's been silting, and it's been silting up, so it's becoming shallower. The answer may seem like going there to dredge, but the moment you dredge it, there's less friction and it runs faster. So as it runs faster, now it starts to scour. So it's a system that's in fine balance. So many times external consultancies or international consultancies will come in and just say, this is the solution, this is what you need to do. Whereas what we were working on was making sure that the local community in Myanmar had enough in-house knowledge to come up with the questions themselves and see what was working and what wasn't working. So I was there doing things like training on how to do numerical modelling, how to actually do field work, looking at what issues were important, We were trying to build up the laboratory facilities at one of the local universities so they could run experiments themselves, those type of things. It takes a while in any training environment for people to build up trust. So you actually have to be there on ground for a reasonable amount of time before people will start coming to you and asking questions. In Australia, we tend to be a very, maybe abrupt is the word, or maybe we don't follow a lot of social hierarchy, and we don't necessarily follow a lot of politeness that we see in other, say, Southeast Asian and other countries, where it's really uncommon for someone to speak against their elder or ask questions that might embarrass themselves or embarrass their elders. So you actually have to be there for quite a while until people will actually start to ask you these questions. So I guess while it was a challenge, it was also after having been in Myanmar for maybe 2 weeks on my second visit that people would start actually asking, oh, do you mind if we catch up over dinner and ask questions and things? And it was almost as productive, if not more productive, than what we were doing during the daytime, because people would ask questions in an informal fashion. The other challenges that always come is that, unfortunately, Myanmar has a special history, or a difficult history, in the sense that while they've got a coup on at the moment, this isn't their first one. And the universities were all closed in Myanmar for maybe a decade, and so there's actually a group of the population that really don't have advanced tertiary education, and so it's actually one of the challenges is actually trying to fill in that gap and make sure that make sure this local knowledge exists.
My name's Chris Drummond, and I'm a senior project engineer here at the Water Research Lab. And my humanitarian engineering experience started after I finished my undergraduate degree. So I did civil engineer at UNSW, and after I finished my bachelor, I decided I wanted a bit of a different experience to my colleagues. I think it's really important as an engineer to contribute to the greater good. It may be hard to realise that when you're sitting in an office designing car parks if you're a structural engineer, or perhaps designing a bridge, or as a water engineer making sure flood impacts aren't impacting upon people. But there's a really tangible benefit when you are involved in humanitarian engineering to, use your skills for the greater good. And I also found that volunteering in Cambodia gave me professional experience that a lot of my colleagues didn't have. It taught me resourcefulness, so it's not also about giving back to the community, it also leads to some skills development within yourself. So I learned how to come up with solutions that were culturally appropriate. I learned how to be resourceful when there's really not a lot of materials around and there's a lot of constraints about what you could use, and also to develop simple solutions. So I found myself in Cambodia after I graduated, and I spent 1 year there volunteering with a local organisation. And so that organisation was called Live and Learn Environmental Education, and they were working in partnership with Engineers Without Borders Australia to try and develop sanitation systems for poor communities that live on a lake in the middle of Cambodia called the Tonle Sap. And so one of the big issues when you live on a floating house is, what do you do with your human waste? And so the issue with living on the lake is, during the dry season, people would live in houses that were stationary on the riverbanks, but during the wet season, due to all the monsoon rain, a lot of water comes down the Mekong Delta and river and ends up in the Tonle Sap, and the lake expands in size significantly in the wet season. And so people live in these fantastic houses that float during the wet season and move around. And one of the things I was really struck with is the fantastic ingenuity that the local people had in building these really large structures that were, fantastic floating homes that they would move around. But one of the issues when you're living in a house that moves around is dealing with human waste. And so you can't have a static sewage system, which we have in Sydney here. You can't have fixed pipes. And so the common practice during the wet season, when you needed to go to the bathroom, you just went over the side of the boat into the lake. And that had some obvious issues where a lot of young children were getting sick from the pathogens in the water, and there's a very high mortality rate with young kids dying from something as simple as diarrhea. But the other issue is that the main source of income for these impoverished communities was fishing, as well as their main source of food. So there's a lot of extra pathogens in the water from human waste. People are eating the fish because that's their livelihood for income, but also their food source. And so there was an obvious need to try and tackle this complicated problem. So Live and Learn Environmental Education was a local Cambodian organisation that engaged with the local community, and they picked a particular community called Pasandai, where there was a local school teacher who was keen to get involved. And so my role in that project was to help develop some form of system to treat the waste before it was put into the lake. And so a technology that's been around for a long time is called an anaerobic biodigester system. And what that means in layman's terms is you capture the waste and you put it in some sort of vessel, and you prevent fresh air from getting into that vessel, and after a period of time the bacteria starts to eat itself and treat the waste through the process of anaerobic digestion. And so after you leave the waste inside the digester for a set period of time, it breaks down some of the pathogens. It doesn't break it down to the extent that we have here in Australia with tertiary sewage treatment plants, but it's a start, and it does kill quite a lot of pathogens. And one of the really cool things about the project is that a byproduct from anaerobic digestion is to create methane gas, and that's something that has a co-benefit for the community, because the main source of energy for cooking was to burn firewood, and that led to a lot of problems with deforestation around the lake, but also health problems where traditionally the women were the ones who would do the cooking, and they'd be in a confined space and inhaling the smoke, leading to respiratory diseases. So we were able to collect the methane and use that as an alternative source for cooking. So it was a win-win in able to treat the waste before it ended up in the lake, but also create a source of energy for cooking. So one of the things that I learnt volunteering and living in Cambodia for a year is when well-intentioned people can sometimes want to help a community in humanitarian engineering, but if it's not done the right way, it can lead to adverse impacts. So an example that I could talk about was there was a really large aid organisation in Cambodia that was trying to help the community on the Tonle Sap Lake. And to do that, they were giving out free solar panels as a way to provide renewable energy. Now that sounds really great on paper, but one thing that I noticed was that it was actually not the best thing to do. So in aid work, if you give something to someone for free, they don't have as much ownership over it, and they don't treat it as carefully as they might if they had to. They don't provide any, it doesn't have any value to them. So not only did a lot of these solar panels start to decay and were in bad condition, when another organisation came in and tried to provide an alternative source of income, they did what's known as microfinancing, where they encouraged local communities members to sell solar panels, for example, to the community. But that program didn't go anywhere, and it actually stopped because no one in the community wanted to buy a solar panel because they said,
for free.
I'll wait until I get one for free. Yeah. So the lesson learnt from this project is when you're doing humanitarian engineering, you really need to make sure you're not giving a hand out, but you're giving a hand up. It's all about capacity building local people rather than giving something for free, and then once you move on to something else, the community don't really know what to do with it.
My name is Francois Flocard. I'm a principal engineer at WRL for 10 years now. I've got a degree in mechanical engineer and then did a PhD in civil engineering, coastal engineering. Well, I would say that for me, humanitarian engineering comes to the fact that we have knowledge that we've been able to acquire and develop methods in our setting. In this case, Australia or Western countries with a certain level of financial advantage and privilege, and basically our role is to better disseminate and share all this knowledge that we've acquired in the past to population, but also places in the world that may not have this opportunity to gain this knowledge through their infrastructure, I would say. So knowledge sharing, I would say, is really important. It's not just like keeping the knowledge in certain place, in certain hands, but the role is to share. The project that I want to talk about are previous work that I've done at WRL in the South Pacific and basically island nation states such as the Cook Island or the Marshall Islands. Most of these projects have been coastal engineering centered, with the goal was to better understand coastal hazards for present day but also future conditions due to a changing climate, and better understand the risk caused by extreme coastal events on fringing reef and the population lying behind. In the specific cases of Pacific nations, Pacific States nation, I would say it's a logistical constraint that we deal with. The supply chain for such places are very different from what we have in Australia. And Australia is already, its own little specific case compared to Asia, Europe, or North America, for the places I know and I've been working with. So this is really taking it to another, I would say, another level in terms of challenge. Is that thinking about, in this case, we're talking about a coastal structure that needs to be built. Those are places where potentially construction materials are scarce. So how can we better design a structure that, say, economically is going to be as efficient as possible in terms of the cost, where we need to take account shipping, but I guess also the environmental aspect of these costs. Shipping, as we know, is expensive in terms of money, but environmentally also it's something that from the get-go, if your structure can be optimized in this approach. So in this case, we looked at the type of coastal structure that was based on very small rock to avoid the need for shipping expensive rocks from potentially the other side of the ocean, Pacific Ocean. So trying to think like this also from the get-go, more than going with this is a typical solution that would work in an Australian port or a European port, after verifying that it works well. Is it even buildable, or does it even economically make sense to try to apply with this?
I'm Jonathan Chan. I'm a project engineer at the Water Research Laboratory. I've been part of the team for 1 year now and have absolutely loved it. A lot of exposure to different projects. Currently working on a physical model project. So yeah, I grew up in Coffs Harbour and moved to Sydney for university, where I went to the University of New South Wales. I studied environmental engineering and computer science. That took 5 years, and did my honours thesis in the coastal engineering space with Dr. Mitchell Harley and Professor Ian Turner, who both work at the Water Research Laboratory. So I think that was my first step in the door to the Water Research Laboratory. So I think humanitarian engineering is important because it brings the forefront of engineering knowledge and understanding and practices to areas and disciplines in the world that wouldn't otherwise get exposure and aren't exactly in a position to have the latest technology and research and understanding. And I feel like, you know, in the Western world we are so privileged to be there, such as at the Water Research Laboratory. We're half academic, half industry based, so we're, you know, constantly being fed with new research, and I think, yeah, it's really important that understanding and research is transparent across the world and reaches non-developed countries that otherwise wouldn't get that exposure. Yeah, so I think it's really important that humanitarian engineering provides that medium for the transfer of knowledge and understanding. So for context, I joined a student-led project. We called ourselves DREW, which is an acronym for Drought Resistant Uganda. And DREW formed off the backbone of the Humanitarian Engineering Projects course at uni. I think it's 4102. And there was a group, and they started DREW. And yeah, we're essentially looking at providing drought resistance options and alternatives for farmers in northern Uganda. Essentially, farming is a huge part of the people's income in northern Uganda and livelihood. There's a lot of subsistence. I got to go to Uganda with 4 other lovely people and essentially install 2 weather stations. It was Jasper and my job prior to the trip to work out the best locations to install them. And we were pretty naive at the time, but we were looking at things like topography, previous rainfall data that they had from satellites, groundwater levels, where the bores were located, like where it would be most useful, where the highest density of people were. So essentially just made a GIS map with a bunch of layers and went, oh yeah, these look like good areas. In the end, it was dictated by the security, the safety of where the weather stations would be. So one of them was at a hospital that the Love Mercy Foundation actually started, and the other was at a community warehouse. So both, in terms of the research that Jasper and I did, were good locations, you know, high topography, relatively high rainfall based on the satellite data, and high density of farmers. But, you know, at the end of the day, it was that security that dictated where they were going to be.
I think being able to help local communities for improving their conditions, and for me it's around water. Whenever we've actually made progress, I think that's been immensely rewarding. And I see this part of my work as, you know, lawyers have a pro bono, they do pro bono stuff. I feel this is my sort of pro bono work to help these communities. And I think also some of the connections that we built, especially to the elders in Walgett, I always enjoy going up there and meeting with them and catching up with them. To me, that's been very rewarding.
I guess the main thing about humanitarian engineering is really it's appreciating what we've got, both in the terms of our assets and in environment and social structure and our education. And taking that appreciation and helping somebody else with it. Helping somebody who hasn't had all those opportunities, and helping them develop in their own personality and their own skill set, so that they can then look after their own things. So, yeah.
Keep doing what you're doing. It makes a difference, and it does change people's lives. Even if it's a very small change, it does make a difference, and people are genuinely appreciative when you come and you're here to help. They do appreciate it, regardless of whether they understand your language. They know that you're there, you're making a difference, and you're trying to improve their livelihoods. So keep going.
I think the most rewarding part of being involved in humanitarian engineering is the sharing of knowledge. I find that always appreciate in my career, at this stage in my career, to start to be giving back, because I am aware of the privilege that I had through the opportunity to do my studies, and being able to follow this career path of during my studies, getting knowledge, but also practically during my years as a practicing engineer, getting knowledge from colleagues or collaborators. So I think it's really important to be able to disseminate as much as you can the knowledge, the positive one, but I would say also the negative one, meaning the mistakes. Is that there's no point being shy of mistakes or failures, and I think that's really the most important for me, is sharing the knowledge.
I think I'm more considerate and I guess empathetic of other people's circumstances, and not like projecting my opinions and ideologies of what's better and what's not. Like, everyone has their own norms and perception of happiness and what brings them happiness, and I think particularly with that group going to Uganda, we had our own ideas of things that would improve their living conditions, but some of those were us projecting what we thought, and it wasn't until we got there that you have to interpret what they value, and then tie that into how you could potentially like enhance their living conditions.